Alright, the number of machines infected by a specific computer virus can be modeled by the equation C of D equals 6.8 plus 20.1 natural log D. So I'm just going to box that. It's a little bit important here. Where D is the number of days since the first machine was infected. About how many machines were infected on day 12? What do I do? Plug in 12. So I want to know what C of 12 is. Now, again, you are not going to get Desmos. So how would you do this if you don't, bless you, get Desmos? You just do what I just showed you right here. That's it. That's all you would be able to do. That would be the answer, but we have Desmos on homework, so you can plug it in on homework. So,
it's not realistic.
If this will work, thank you. All right, so I'm going to plug in, what is it, 6.8? 20.1 natural log. Did I go too far? Natural log of 12. And I get, so 56.7, how many computers have been infected? What? 57 computers. You're not going to round down because if point something of a computer is infected, wouldn't you say the whole thing is infected? Or, sorry, not computers, machines. Alright, next question. How many more machines were infected on day 30 than day 12? What do I need to do? So I'm going to find C of 30, which is 6.8 plus 20.1, natural log of 30. And then if I plug 30 into Desmos, I get... So if 76.1 computers are infected, how many computers are infected? 75.1. Then how many computers are infected? 76. Because if a computer is 0.1% infected, don't you think it's infected? Sorry, machines again. Now, is that my answer? No, because what is my question? How many more? So what do I need to do? What is 76 minus 57? It's what? 19 more machines. Are we okay with that? This last problem says on what day, so what am I looking for here? On what day will the number of infected machines reach 100? So the machines equal 100. So I'm going to set it equal to 100. How do I solve for D? By the way, we're going to be solving next week on Wednesday. But you should mostly know how to solve this. Which gives me 93.2. And then we are going to divide by 20.1. And 93.2 divided by 20.1 is, we'll say 4.6. Now, yes, that is the correct word we're going to use. So a lot of people say raise it to the power of. Okay, that word, what we're going to be doing is exponentiating. How do we get rid of the natural log? What's the inverse of the natural log? E. And so what we're doing is we're raising this up here as a power, meaning we are making it an exponent. That's called exponentiate. And what you do to one side? So those cancel, and I'm left with D equals. Now everybody look up real quick. Again, you might have this on your homework. You won't have it on the test. But if I put E raised to the 4.6, that is wrong. Why? I rounded up here. Do you agree? So let's just make this out front. Let's make this A equals. If I do E to the A, look at the difference in the answer. So your rounding does matter. All right. Now, on what day will the number of infected machines reach 100? Okay, so do you agree machines are whole things? Do you agree days are continuous? You can have half a day, right? So in this case, I'm just going to round it like normal. So I'm just going to do 103 days. I just wrote 130. 103 days. Again, are you going to have to worry about rounding and all that on this test? No, because all you're going to be doing is correct. All right. We are done with this sheet. This whole sheet is what your homework is over tonight. It's also what your quiz is going to be over next, maybe Monday. Okay? I would now like you to get out your blue notes from Exponents, these right here, and turn to the second page. If you don't have them, you can just get out a sheet of paper if you want, or look up. Ow, my eye. All right, we're going to go to the second page where it has the definition of logs. We talked about this yesterday, but the definition of the logs is if you have a base raised to an exponent, that's your answer. And if I want to turn it into a log, what do I need to do? How do I turn this into a log? Do the little loop, or do the cloud. Your base, the log of your base to the A equals P. If you have a log and you want to find the exponent, you start at the base. The base to the power is your answer. Okay? Now, properties of logs, again, we did this yesterday. Log base A of A to the R, what can I do here? Cancel, so what do I know? R equals R. What about a base A raised to the log of base A of M? M equals M. Does that make sense? Okay? What about a log base A of 1? Why does that equal 0? Anything to the 0 power equals 1. And why does the log base A of A equal 1? So 2 reasons. You can either do the loop A to the first power equals A. Do you agree with that? Or, couldn't I put an exponent of 1 right here? Don't those cancel? What are you left with? 1. So you could also say 1 equals 1. Okay? Yeah, you can do either one. 1 equals 1 or A to the 1 equals A. All right, now, properties of logs are just like properties of exponents. So the first one is your product property. When you are multiplying two things, what can you do to your logs? Separate and add them. So for instance, if I have the log, we'll do the common log of 6. How can I make that multiplication? The common log of 3 times 2. And how would I expand that out? The log of 3 plus the common log of 2. And that's it. The quotient property. If I am dividing two numbers, what can I do with the logs? Separate them and subtract. So again, if I have the common log of 6, but I want to divide this time, what can I divide to get 6? 12 and 2. So I'm going to say the common log of 12 divided by 2. What is 12, or what did I expand this out to? Common log of 12 minus the common log of 2. Sometimes I'm going to ask you to expand. Sometimes I'm going to ask you to compress, meaning make it shorter. So sometimes I'm going to give you this, and you're going to have to end up this way. So it goes forward and backwards. Okay. The power property of logs. If you have a log base m raised to the r, what can you do with that exponent? Move it to the front. That exponent can go out to the front. So if I have, I don't remember what I used last period, let's see. If I have log, the common log of 6 to the third power, how can I rewrite that? 3 log common log 6. Just move that exponent out front. What if I have the natural log of the square root of 5? Do y'all agree that's the natural log of 5 to the 1/2? And what can I do with that 1/2? Does that make sense? So if I ever ask you to expand it out, you should never have any exponents. You always move them to the front. Okay? The equality property of logs, or we also call this the one-to-one property. Just like with exponents, the one-to-one property, what was my rule? It has to have the same base and 1 on each side. Well, this has to have the same log with the same base, 1 on each side. So if I have a log base a of m equals the log base a of n, and they have the same base, they can cancel. So m equals n. But remember, you can only cancel 1 log on each side with the same base. If they don't have the same base, you cannot cancel them. Is this color combo hurting your eyes, or y'all okay? It's okay? When I look up there, it does. Down here, it looks great. But I'm at a kind of a weird angle, so. Last but not least, you have your change of base formula. Your change of base formula you're going to use if you want to change the base. And you can do this with anything. So like if I have the log of base 2 of 9. Can you turn 9 into 2? No, and I don't want to, you can just change this to any base, the log of, it doesn't matter. Let's do, okay, we'll do common log because I already wrote log. I can do the common log of 9 over the common log of 2. Now, why would we do that? Sometimes I'm going to ask you just to change the base. But on yesterday's worksheet, do you remember when we did this problem right here at the very beginning of class? And I told you, hey, if you can't turn this into 27, make it equal x and do the loop. Do y'all remember us talking about that? Well, now I'm going to show you another way to do it. So, the problem was, I'm going to draw a line right here. The problem was log base 27 of 9. Can I cancel them out? Can I make them into each other? No, but I can change the base so that they have a base that they can both work with. What base do both of these turn into? So I can make this the log base 3 of 9 over the log base 3 of 27. By the way, your original base is always going to go on the bottom. Now, I can rewrite this, the log base 3 of 3 squared over the log base 3 of 3 cubed. And what can you do? And it equals 2/3. And if you look at the paper we did yesterday, example 1, number D, we got 2/3. Some of you, because we just got done with the expo unit, some of you are going to prefer doing this. Let me just change it to an exponent, get the same base, and solve. Some of you are going to really like this. You can do either one, I don't care. Whatever you prefer works for me. Okay? Alright, those are your properties of logs. So now, if you can get out your notebook, we are going to do 9 examples.
9 examples of homework?
9 examples. This is your Wednesday homework. Properties of logs, page 30. Page 30. Guess what page we got to in geometry today?
64. 62. Even or odd? Yeah, even or odd. Oh, how come you want my guess?
But do you know how much of a big deal it was? They're like, we've been waiting all year.
You guessed it first. Hey, what do we get? You should have skipped it.
I should have, like the number 13 on elevators.
We should have gone from 66 to 16.
Alright, they would have been so mad. Properties of logs. Again, we are going to do 9 problems. Is that what I said? 9 problems.
When did you get to page 67?
3? I didn't. Definitely didn't say 3. Alright. Shh. Look up, please. If I'm going too fast, please speak up today. She just roll her eyes at me. Mm-hmm. Mm-hmm. Alright. I guess I'll use purple. I'm a black pen. Okay. What do I do first? It's adding, so I'm going to have to multiply. So this is going to become the log base 6 of 4 times 6. That's not a 6, that's a 9. Man. Shh, boys. That's log base 6 of 36. By the way, do you see how I have a parentheses right here? You have to have the parentheses. If you don't, then it looks like you're just taking the log base 6 of 4 and multiplying it by 9. So just be careful with that. What is that? Oh, 6 squared. And my answer is 2. No, that's it. We're simplifying. What questions can I answer? Alright, example 2. Is this too small? Do I need to zoom in? Yes. Okay. On this one still? Or the other one? Okay, there you go. Alright, what do I do first? I'm going to have log base 8. And by the way, when you divide and you get 1 log. So 2 subtracting turns into 1 dividing. Don't do log base 8 of 20 divided by log base 8 of 5. It's just going to be 20 over 5. which gives me log base 8 of 4. We can do this two different ways.
We can do the exponent or the one we just learned.
I'm gonna do the one we just learned. Okay? I'm gonna change the base here. What number do both of these have or can have as a base? 2. So I'm gonna change this to log base 2 of 4 over log base 2 of 8. Which equals log base 2 of 2 squared over log base 2 of 2 cubed. Cancel them, and what do you get? 2 bits. That is the change of base formula. Again, do you have to do it that way? No. Man, where did that pen go? Alright, what is another way I could do this? I could just turn this into an exponent. I can make this equal x and do the loop. Remember, your loop starts at your base. So I would do 8 to the x equals 4.
Yes. Uncommon.
This becomes 2 to the 3x equals 2 squared. Three x equals 2. Therefore, what does x equal? And my pencil's out. Do y'all agree? Either way, we got the same answer? Do you have a preference? So it's up to you. Whichever way you like, you can do. Do I have any questions? All right, here's example 3. E raised to the negative 2 natural log of 3. E raised to the negative 2 natural log of 3. Okay, we can't cancel these out just yet because we have this negative 2 in the way. But what can we do with the negative 2? Move it to what? It is already in the front. So forget that there's an E right here.
I keep thinking that's the back for this.
Yeah.
The front, the back.
What am I going to do with this right here?
Make it the exponent.
I'm going to make it the exponent. So this is going to become E to the natural log of 3 to the power of negative 2. What do you think people do as a mistake here? No, you are supposed to square it. They multiply it. And I'll show you why that's wrong in a little bit. What can I do next?
Now you can cancel it.
Now they're right next to each other. I can cancel it out. And I get 3 to the negative 2. Well, what's 3 to the negative 2? 1 over 9 is my answer. So what a lot of y'all do here is y'all cancel E and ln and you do negative 2 times 3. You can't do that. You cannot cancel when you have to run through that negative 2. Okay? The log base 2 of 1/2 to the 5th. And I want you to do these next two on your own. The log base 4 of the 5th root of 64. Let's see if you can do these two on your own. These all are simplified to a number. Yes, these all should simplify to a number. What is it? Is it that thing up there?
Okay, that's good.
Is that it? Yeah, you can grab it. They found it on the floor. Okay. Here's Edwin. Oh, never mind. We're recording. I'll tell you after class. Yeah. In public? Out in the... What do we call it? Out in the real world? Do y'all agree 1/2 is 2 to the negative 1? By the way, I would be okay if you did this in one step. Do y'all agree that that is 2 to the negative 5? Cancel them out, and what did you get? Is that what y'all got? Okay. For number 5, do you agree I can change this to the log base 4 of 64 to the 1/5? What is 64? So the log base 4 of 4 cubed. Oh, I should have kept that on here. 4 cubed to the 1/5. Sorry. And what can I do here? I can just cancel them. And that gives me what? 3/5. Yeah, you could. That's why I did. You could move it out and put it 3/5. Again, I'm doing extra steps just because it's notes. You don't need this many steps sometimes.
One more to go. Next one.
Any questions? Oh, maybe I'll get to 11. That means less on Monday. Future you will be thankful. Alright. What about e to the natural log of 3 plus natural log of 4?
Oh,
Kylie, Ava, stay with me. E to the natural log of 3 plus natural log of 4. Yeah, for a second, forget about your e. What are you going to do here? Natural logs are still logs. I can multiply them. So that gives me e to the natural log of... I'm going to do it in 2 steps. Again, I would be totally fine with you doing it in 1 step. And what does that give me? Y'all want to guess what people always tell me this is? They do 3 plus 4 and they say it's 7. Can't do that. Okay? The last one for me on this page.
Is that e squared?
Yeah. So 5 natural log of e squared minus the natural log of e to the 3rd. Okay.
Oh wait, this is not that.
Be careful. I need everybody to look up real quick. Just look up real quick. Don't write. Just look. What am I going to do with this 5?
You multiply that with the exponential.
Okay. So, do I multiply it or do I make it 2 to the 5th?
Isn't that the same?
So I want to know. Do I make this 10 or 32?
Oh.
32.
Is it actually 32?
Okay. I need everybody to look and shush. Look. Up here, when I, forget the E, when I did this, do you agree I had the natural log and then next to that was the 3? So what's out front, I have to raise that up and make it an exponent. Here, I have a natural log of E. That has an exponent already, so I'm multiplying the exponent, or this with the exponent. Do you see the difference? Let me say that again. This this 2 is an exponent. I'm going to multiply it. Over here, this 3 is not an exponent. I need to raise it to that.
Oh, yeah.
So if it does not, like if that's your number, you are going to raise it. If that's your exponent, you multiply it. So this is going to become the natural log of e to the 10 minus the natural log of e to the 3.
Is it like this?
What now?
Wait, but divide by like
What now? Don't make your life complicated. It's already complicated enough.
e to the 10.
Don't make your life complicated. Bam, bam. What is 10 minus 3? Now, could you divide and then subtract and then cancel? Sure. But if you have a natural log and e next to each other, get rid of it.
Yeah, you're right.
Make your life easy. There's no need to do more work than you have to. Okay, I got to turn over. If you can keep going, that's fine. But if you got to turn over, can I change this? All right. Not your quiz on Monday, but your quiz, your second quiz. You are going to be asked to condense the following logs. What does the word condense mean? Get smaller. You are going to shorten these logs out. What are we on? 8?
We can do 11.
It's an A. How would I condense, shorten, simplify? Jeremy. Jeremy. Damn. How would I shorten this?
Log of the A, 7 times 10.
Be careful.
Is that an A or a 9?
It's an A, you're right.
41. Power of 41.
So really close. But I gotta raise it to the power of what? Okay, cool. Everybody else understands? Not in my class. Today?
Yeah.
Oh. Alright, by the way, that 1 was the log.
Yeah, I see.
At least you didn't say 410. Alright, now what do I do? Now I'm going to multiply. And if you multiply, do y'all know what 3 to the 4th is?
Yes.
81 times 7 is?
I mean, that's the answer.
Alright, we've condensed this, we're done. If this was a number, then you would keep going to like simplify it, but we can't. It's an A. We can't do anything with that. Alright. Condense means to make smaller. So what about this one? Y'all, do I have any questions? What about 2/3 natural log of 8 minus the natural log of 3 to the 4th minus 8?
We don't get calculators?
You don't get calculators.
I know how to do.
So what do we do? Oh yeah, you can baby calc. What do we do first? What do we do first? 2/3. If it's out front, so this is going to equal the natural log of 8 to the 2/3 minus, what is 81 minus 8? Over here, I'm going to do 8 to the 2/3. Do y'all agree 8 is 2 cubed to the 2/3? Can y'all see that?
Yeah.
What happens to these 3's? It is on. That's why I'm like, can y'all see it? It's on. This is it off. I don't know. I think no, they're all 3 on. It feels like one of them's missing. All right, what's that leave me with? 2 squared. And what is 2 squared? 4. So let me say that again. 8 to the 2/3. 8 is 2 cubed times 2/3. The 3 cancels, so you're left with 2 squared, which is 4. So this right here becomes the natural log of 4 minus the natural log of 73. And now I can divide, but be careful when you divide. What's it going to become? 4 divided by 73. You would be okay. Like, you wouldn't get points off because of it. And that's it. We don't have a calculator. We're going to end it there. Oh, I have 10 minutes. I can do 2. Just 2. Because then we only have to do 4 on Monday. Come on. Just quickly. It's quick. Now, what's the opposite of condensing?
Expand.
We are going to expand now. Oh, I forgot to write it right here. We are going to expand the following logs. What operation is happening here? What? Multiplication where? Do y'all agree there's a multiplication sign right here between these? So what can I do to these?
You can add them.
So I'm going to have log base A of x plus log base A. X squared plus 1. Instead of doing the square root, what can I do? Let me zoom in for y'all. What do I need to do? Move that to the front. So log base A of x plus 1/2 log base A. Y'all look up. If you do not put this in parentheses, it will be points off. Because then I only think you have the log of x squared. Base A of x squared. And this is it. Once you've separated everything and you have gotten rid of your exponents, you've expanded. Yeah. Ooh, y'all want this one? Maybe we should save this one to Monday.
Yes, tomorrow. During scholars. You're gonna have scholars again in the summer.
Yeah, we do it in May again. But for the sophomores.
Why can't seniors come?
No. We'll finish this one on Monday. I don't want to do it right now. Just write it down. We'll finish it on Monday. Alright, what's due on Monday? Homework.